So today we're in section 2.7, perimeter and area of similar figures. So we talked yesterday about the fact that similar figures are not the same size. You guys remember that? They're small and larger. But if they are similar, then the ratios of their side lengths will be the same. And that's what we're looking at today. The first thing you need to understand is what is perimeter and what is area. They are not the same thing. Okay, so if I had a figure, I'm just going to draw a quick sketch of a rectangle. If I had a rectangle, the perimeter is the distance around that object. That's perimeter. The area fills the surface of that object. So the area would be what I'm highlighting in pink. Okay? Is this familiar to you guys? You probably learned this in prior years. Okay, so perimeter and area. So what I'm going to do in these examples is I'm going to compare the perimeters, all right? And it's going to be real specific on which figure to start with. So if it says from orange to green, I know that orange comes first and then green. I'm going to put that into a fraction. 4 over 6, all right, 4 over 6, and I'm going to reduce it. And that is the ratio of these side lengths, okay? And what it means by perimeter is it just means that this is an outside side length, okay? It's a distance around an object, perimeter. All right? Good so far? That's it. That's your answer. Okay, so when I'm comparing perimeter, now I don't have objects to look at. There's no picture for me to look at, so I really have to read this information. And again, I'm doing a comparison and it will tell me the order. So it says the height of figure A is 9 feet. The height of a similar figure B is 15 feet. So here comes the order, here comes the directions. What is the value of the ratio of the perimeter? So there's my perimeter of A to the perimeter of B. So I'm going A to B. How can I put that into a fraction? It didn't say B to A, it said A to B. So how can I put that into a fraction? Michael?
9 over 15.
9 over 15. But that's not my final answer. I must reduce it if I can. So it reduces to
3 over 5.
3 over 5. Okay? And you could say feet. You could label it. Okay? 3 over 5. And that's my ratio of perimeters. You say, well, that's not the full perimeter. I'm not solving for perimeter. All right, but remember, that is a side length, okay? Height is one of the side lengths of this figure, and perimeter is distance around a figure, okay? So that is one of those distance measurements, all right? Okay, so that's example 1. Now in example 2, I'm comparing, the only difference here is I'm comparing the areas. Remember, guys, what is area? Is it the distance around an object? No, it's the surface, okay? So I start off the same way that I did for perimeter. What does it say? Does it say green to orange? What does it say? It says orange to green. So I put that into a fraction. Orange to green, okay? And I'm still going to reduce that fraction. What would it reduce to? 3 over 5. Guys, this is perimeter, isn't it?
Yes.
The last step to find area, because remember, it didn't say perimeter, it said area. The last step would be to square the perimeter, okay? So I find perimeter, but then I have to square it to find the area. Remember, area is the amount that fills in the object, okay? So it's going to be 3 squared over 5 squared. So what's 3 squared?
9.
So area equals 9 over, what's my denominator?
25.
25, okay? That's my area. On your homework, it's going to ask for both in one problem. So my area was 9 over 25, but does anybody remember what my perimeter was? 3 over 5. So let's go ahead and pull that one into our answer also. Even though it didn't ask for it, this is what our homework is going to ask for. I have changed one of your homework problems from number 7 to number 8. Okay, so just make note of that, and then we'll talk about that again at the end of class. So I did change one. Okay, all right, so that's comparing area. Now let's talk about this modeling real life question. Okay, now this deals with proportions. You guys remember proportions, all right, where it's two ratios. So I've been dealing with ratios in this lesson that I can make equal to each other. Ratios equal to each other. Here's my main rule. I must compare the same values on both sides of my proportion. So I'm going to give you a verbal model first of what we're doing here. Okay? Guys, there is not just one way that I could set this up. There are actually multiple ways that I could set this up. Okay? What it's asking me to solve for is the perimeter and area of the pool. Okay? So the pool's up here. The only dimension I have for the pool is what? 18 yards, which is the width. Okay? Now, the tennis court, I have a lot more information on the tennis court. I know the width, but I also know its area, and I also know its perimeter. That's going to be really important. So the first ratio I want to set up is I'm going to set up a ratio for the pool that involves what I want to solve for. Okay? So I'm going to go the width of the pool over the perimeter of the pool, which I don't know. I don't know the perimeter of the pool. And I can do this as long as on the other side for the tennis court values, I do width over perimeter for the tennis court. Okay? So what is the width of the tennis court?
10 yards.
10. And what is the perimeter of the tennis court? 60. So guys, do you see what I did there? Width of both over perimeter of both. All right, so here's where your answers could be different on a quiz or a test. You could have done perimeter over width on both sides. Okay? You could have done width of the pool over width of the tennis court. And then as long as it's perimeter of the pool over perimeter, there's a lot of ways you could set this up. Okay? In my opinion, I like doing here's one object, here's the other object. Okay, width over perimeter, I'm ready to go. The way that I solve this proportion is by cross products. Okay, cross products say I can multiply the terms that are diagonal from each other and put them into an equation. What is 10 times P? 10P. Okay. Now 18 times 60, I will allow calculators on your Chapter 2 test. You're really not going to need them for much other than just little simple multiplication like this. Does anybody have the 18 times 60?
I do.
Okay, what is it?
1,080.
Yes, it's 1,080. So just go ahead and write that down and realize that if you're solving this on your own, you'll need to actually do that multiplication. Okay? Now it's just a real simple one step. How do I solve for P? Josh, how would I solve for P?
You would divide 1,080 by 10.
Very good. Divide both sides by 10. Guys, do you know the shortcut on how to divide powers of 10?
Zeros?
Yes, the zeros cancel out. If you have a 0 up here and a 0 down here, they cancel. And now your answer is just 108. Okay, so that's how you can real easy do the mental math. So the perimeter is 108 yards. What does that mean? That means if this ratio, guys, please try to get this, okay? If you can understand the connection. That means if these figures actually are similar, according to these values, the perimeter of the pool, I did not measure anything. I don't know what the length is, but I can use these ratios to determine the exact perimeter of the pool. That means if I were to walk this, this is the perimeter. So I can use ratios to find a value that I actually did not measure. if I know that they are similar. Do you see that? Deasia, is that making sense? Allie, Kelsey, is that making sense? Okay. So I found perimeter. Now we need to find area. I want you guys to work together. I've given you, actually, I'll put it back up. I've given you what the proportion should look like. I want you guys to work together and try to set up your proportion for finding area now. So you're going to use a different value here in your ratio for the tennis courts. Okay? Not going to use perimeter anymore, are you? Because you're not solving for perimeter. You're solving for area. All right, go ahead and try to set up your proportion, and then we'll finish up the lesson. Anybody think they have the proportion? Micah?
18 over 8 equals 10 over 200.
Okay, he said 18 over A equals 10 over 200. Would you agree that he compared width over area, okay, that's the pool, and width over area of the tennis court? Do you agree? Did anybody have anything maybe a little different? Did you do area over width?
No.
Or did you do your widths over your areas? Okay. All right. So if you don't have this proportion written down, go ahead and write it down. He is correct. Okay. Go ahead and write it down. Did anybody else get the proportion? Anybody else get it? I see a few nods. All right. That's great. Okay. But here's the problem. These width values are perimeter values. Do you guys remember what I can do to a value to make it the area value? Yes, I must square it. I have to square these values, okay, in order for it to be a true area value. So 18 squared, all right? 18 squared, anybody have that? What's 18 times 18? Okay, I was close. No. 18 times 18 is 324. Okay? 324 over A equals, we should all know 10 squared. What's 10 squared? It's not 20. 100 over 200. Okay? 100 over 200. Now, do you remember what to do? Yes. Do your cross products and solve. All right, so go ahead and do your cross products and solve. Guys, do you know the mental math shortcut for multiplying 324 times 200?
Yes.
Okay? All right, so here's the mental math shortcut. You're going to double each of these numbers. You're going to multiply each digit by 2. What's 3 times 2? 6. What's 2 times 2?
4.
What's 4 times 2? 4 times 2 is 8, and then you bring down your extra 2 zeros. You can do that when you're multiplying by powers of 10 like this, okay? So you literally just multiplied a number and got 64,800 without using a calculator, okay? And now 100A, okay? What do I do, Nick, to solve for A?
Oh, you divide
Divide by what?
100
Divide both sides by 100.
and you get
Okay, do you know how to do mental math to do division by 100?
Yes.
Take away the zeros.
Take away the zeros, okay? So this is a pair of zeros, they cancel. This is a pair of zeros, they cancel. So my answer is what's left because all I'm doing is dividing it by 1. So A equals 648 yards squared. Again, I figured out the area of the pool without taking a single measurement. That's the benefit of using ratios of similar figures. If they weren't similar, I never could have done this. But knowing that they're similar figures and knowing that their ratios are true, I can actually take measurements without even measuring. Do you get that, guys? That's the whole point of today's lesson. Okay? All right, so we're going to start on homework. If it's okay with you, I'm going to give you a little bit of help.
Oh, yay.
Okay? Yeah, I'm going to do number 2 with you.
Oh, thank you.
I'm going to do number 2 with you.
We have to
So
draw the graph.
go ahead and start. You do not have to draw the graph. Okay? Go ahead and set up your homework, and then we are going to do number 2 together. And I'm going to leave it a part of the
They said
recording also.
Take out number 7 and make it number 8.
Yes, we are not doing 7. We're doing 8 instead. So number 2 says to describe a similarity transformation to get from the red figure to the blue figure. To get from red to blue. Do not shout out answers.
I'm sorry.
You've been doing that the whole, okay? All right. So how could I get, again, don't say the answer out loud. And the order in which you do these transformations technically doesn't matter either. All right, I'm going to do it in a certain order, okay? But how could I get from red to blue? I just want you to write down what you think the first transformation would be, okay? So there are 2 transformations happening, okay? What do you think the first one would be? Anybody have an idea? Want to raise your hand? Tell me what you think the first transformation might be. Micah, what do you think? Yes, it is a rotation. So that's the one I want you to start with. Go ahead and rotate this figure 90 degrees clockwise. And I want you to see, get a visual on what's happening here. I'm taking this red figure and I'm turning it on its side. Okay? Do you see that, guys? All right, so a rotation of 90 degrees clockwise, yes, it turns it, but does it make it match the blue figure? Does it make it match the blue figure? No, it doesn't. Okay? It doesn't at all. So there's 2 ways that you can figure out how to make the red figure match the blue figure. Okay? And what do you notice about the red figure compared to the blue figure? What do you notice about it, Nick?
It's bigger.
It's a lot bigger, isn't it? So what we talked about yesterday, guys, is that in order to figure out a dilation, okay, so I already know that they're similar. I just have to tell how. Could I count the corresponding side lengths? So as long as I'm comparing the same side lengths, I could figure out this dilation. So again, I got to compare the long side. How many units long is the red figure? 4. All right. Now, how many units long is the blue figure? 2. So let me ask you this. What scale factor could get me from a 4 to a 2? What is it? Tell me. K equals, everybody? 1/2. Okay? Because I have to divide. If your answer is I'm dividing, then your scale factor is a fraction. If you're dividing by 3, your scale factor is 1/3. If you're dividing by 2, your scale factor is 1/2. So then the second transformation is a dilation, and K equals 1/2. Does this make more sense than yesterday?
Yes.
Okay, so yesterday we did the ordered pair, and then we looked at how the ordered pairs were changing, and that works too, but I think this way is maybe a little easier, okay, to do it this way. All right, so great job on number 2. You guys listening? Number 13 is very similar to 12, so I'm going to help you set up 13 so you know how to set up number 12. On number 13, it gives me a ratio in the original problem. That is my first ratio. 8/5. Okay? Now I have to take the values in the figures and make another ratio. Okay? And so what I'm going to do is the first value in the first figure, that's going to go on top. Okay? And then, the second figure is going to go on bottom. And now I can do, what was that method that I said I can do to solve a proportion? Cross multiplication, cross products. 8 times 16 and 5 times x. Okay? And when I do that multiplication, guys, I get 5x equals 128. It's okay if these answers are decimals. Don't think that your answer is wrong. If it's a decimal, we divide both sides by 5, and my answer is 26.5. Or, I'm sorry, 25.6. 25.6. Okay? And that's my answer. All right, so that's how you would do number 12. Number 14, just read the problem and read what it's asking for. It says you have similar foosball tables. The ratio of the corresponding side lengths is 10-7. What is the ratio of the what? What is the ratio of the... Nope. On 14. What is the ratio of the... Areas. So remember what you have to do to the ratio in order to find area. All right, that's everything you need to know
Can you leave that on the board?
for 2.7. And that's the last lesson in chapter 2, guys.
Yay.